Hello and welcome to section 7.1.4. Today we're looking at composition of functions, and then we're also going to look at proving inverses after this video. So the first thing we want to look at is what a composition of functions is. So it says we have two function machines, f of x equals 5x minus 3, and g of x equals x minus 1 quantity squared. And they're shown right here on the right. Suppose f of 3, not x equals 3, is dropped into g of x. This is written as g of f of 3. What is the output? So if you notice, this is what we have here. We're putting 3 into the input as the f function. Whatever that output is then going to be put into the g function, and then we're going to see what our answer is. So when you're doing a problem with these compositions, always kind of cover your finger up and slowly move to the left. So it says I'm putting a 3 into the f function. So 3 is going to the f function. So the first thing I'm doing is f of 3. And again, that's kind of what this function machine is showing. 3 is going in for all my x's. So I'd have 5 times 3 minus 3. So 5 times 3 is 15 minus 3 is 12. So 12 would come out the bottom here. And now 12 is the input to the g function. So now I'm doing g of 12. So I took that output, put it as the input. And again, I know it's going to the g because if I keep moving over, I have g right here. So I now have 12 minus 1 quantity squared. 12 minus 1 is 11. 11 squared is 121. And then I just write my final answer using that proper notation of g of f of 3 equals 121. And again, that's saying I put the 3 into the f function, that answer goes into the g function, and 121 comes out. All right, second part says using the same function machine at right, what is f of g of 3? Be careful. The results is different from the last question because the order in which you use the machines is now switched. Because if you look at here, if I'm doing f of g of 3, I'm starting out with a 3, but that's going into the g function first. So I have to find g of 3 now first. So it's kind of like these function machines are reversed. G is on top, f is on the bottom. So g of 3 would be 3 minus 1 squared. 3 minus 1 is 2. 2 squared is 4. And then I'm putting 4 into my input for the f function. So I'm now going to do f of 4. Again, that answer is the input. So I have 5 times 4 minus 3. 5 times 4 is 20. 20 minus 3 is 17. So I write my answer. Again, now I'm doing f of g of 3 equals 17. So down here we have a couple practice. I'll do a couple with you. So we have 3 functions, f, g, and h. And the first one, I'll just maybe do 2 with you here, is f of g of negative 3. So again, cover up your whole thing. Negative 3 is my input into the g function. So that's the first thing we're finding, g of negative 3. So that's 3 times negative 3. Or g of negative 3 equals negative 9. Negative 9 is now going to be the input into my f function. So I'm going to have f of negative 9. So that output goes to the input. And I have 2 times negative 9 minus 1. 2 times negative 9 is negative 18 minus 1 is negative 19. And so my final answer should be written as f of g of negative 3 equals negative 19. You must write your final answer that way. This is the notation that says negative 3 goes in the g function, that answer goes in the f, and negative 19 is my answer. We'll do one more. We'll do f of h of 7. So I'm doing 7 is the input into the h function. H of 7 is what I'm doing first. 7 squared plus 1. 7 squared is 49 plus 1 is 50. And now 50 is the input for my f function. We have f of 50 is equal to 2 times 50 minus 1. And 2 times 50 is 100, minus 1 is 99. Again, we just want to make sure we write our final answer using the proper notation. F of h of 7 equals 99. That's our basic compositions.